Lesson 73, Chapter 8.6. We are solving rational equations. Now, we have been solving fractional equations all year long. Solving the rational equations is going to be similar, but with a few slight differences. For example, if we had a problem like that, that's what you've been working with all year long, off and on. First step, get rid of the fractions. How do we get rid of the fractions? You multiply by whatever the common denominator would be. And what would the common denominator be in this case? Well, you simply take that denominator times that denominator. So the 2 times 3, we would multiply everything by 6, and then we were able to start reducing. And now sometimes you might have something like this. And while you could multiply the 2 times the 4 to get 8, we really did not want to multiply everything by 8 because one of the factors of 4 is 2. So because of that, the 4 took care of the 2. So we didn't want to multiply everything by 8, we just want to multiply everything by 4. That would be the smallest common denominator. So with all that in mind, we're going to follow that same idea with today's lesson, solving rational equations. But there is one extra catch that I want to point out before we get started, and that is you do have to pay attention to your final answer and make sure that it is acceptable. In other words, looking at this, if we ended up with x equals 0 as an answer, that would be a problem because if we plug that in up here, we would be having 3 divided by 0, which is unacceptable. You cannot divide by 0. So whatever your denominator is, you got to make sure your answer is acceptable. So anything else we get for x would be fine for this problem, number 1. But x equals 0 would be unacceptable. All right. Moving forward with this. Again, now this is solving a rational equation. What really makes it be considered rational is that they are fractional equations, but we got variables in the denominator. That's the catch. All right, so what would be our common denominator? Well, this one says we need an x. This one says we need a 5. This one says we need an x, but I already got it. So my common denominator would simply be 5x. I don't want to get a common denominator of 5x. Instead, we're going to multiply everything by 5x. So the first term gets multiplied by 5x. The second term gets multiplied by 5x. The third term gets multiplied by 5x. The whole point in doing this, cancel the fractions. So for the first one, the x's cancel. So we are left with 5 times 3, which is 15, plus second term, the 5's cancel. So what we're left with is x times 8, which is 8x, equals. And then here, the x's cancel. So what we're left with is a negative 5 times 13, which is 65. Now we have an equation without any fractions. Much easier to solve. So subtract 15. 8x equals negative 80. Divide both sides by 8. X equals negative 10. Now, is that our answer? Maybe. We have to make sure it is acceptable. Looking back up here at our denominators, again, what was not acceptable was x equals 0. So we did not get that. Then our answer of x equals negative 10 is acceptable. Next problem. Now, this case, number 2, I just simply have one fraction equals another fraction. Traditionally, if I'm doing that problem, I'm going to cross multiply every time. But in the spirit of what they're trying to get us to do here for this lesson, solving rational equations, I'm not going to cross multiply. But you'll notice my final result will actually be basically the same thing. Instead, I'm going to do as we did before. I'm going to identify what would be my common denominator and multiply both sides by it. This term says I need an x plus 1. Now, that's not an x and a 1 separately. It's an x plus 1, operating as a single term. This one says I need a 4x plus 5. So what's my common denominator? All of that, an x plus 1 and a 4x plus 5. So the left side needs to be multiplied by an x plus 1 times 4x plus 5. The right side needs to be multiplied by an x plus 1 and a 4x plus 5. Now, when I do that, on this left side, the x plus 1's cancel, and I'm not going to distribute yet, but it leaves me a 3 that's being multiplied by the 4x plus 5 equals. On this side, the 4x plus 5's get canceled, leaving a 9 that's being multiplied by the x plus 1. Now, you'll notice if we had cross multiplied, we'd be sitting at the exact same step. So again, it really doesn't matter, but I don't think you're going to see too many like that. So do it the way that we're doing for all these solving rational equations. And now though, solve for x. So we're going to distribute the 3 and distribute the 9. We just have a linear equation at this point. So get all your x's on one side of the equal sign. Doesn't matter which side. Get your constants on the other side. So in this case, I'm left with 3x equals a -6. Dividing by 3, our final answer is x equals -2. And again, I ask, is that acceptable? Actually, a better way of asking this question would be, what is not acceptable? Looking back at the original problem, I'm going to erase that so I can actually see it. Whatever your denominators are, the denominator cannot be 0. So x plus 1 cannot equal 0, which means x cannot be -1. Because if I plugged a -1 right there, -1 plus 1 would be 0. So x cannot be -1. What about the other fraction? Well, 4x plus 5 cannot be 0 either. Move the 5 over. 4x cannot be -5, divide by 4. X cannot be -5/4. So though anything we get for x will be an acceptable answer except -1 or -5/4. So the fact that we got x equals -2 is acceptable. That is the answer to this problem. But again, we always got to check that. Number 3. Yeah, I probably need a little extra space. Again, we are solving rational equations. Now, in this case, this term doesn't even have a fraction, so I'm not really that worried about it. This one tells us x cannot be 5, because if I said x minus 5 equal to 0, I would get x equals 5. This one tells me x cannot be 0. So as long as I get any answer other than 5 or 0, we will be fine for this problem. Okay, you don't need to necessarily write that every time, but you need to be aware of it. So x cannot be 5 or 0. What is my common denominator? Well, again, this one doesn't have one. This one says I need an x minus 5. All of that operates as a single term. This one says I need an x. I don't have an x yet. All I've got is an x minus 5. So I also need an x. So all of that will be my common denominator, which is what I'm actually going to multiply by. All three terms. So the first term gets an x and an x minus 5. That one gets an x and an x minus 5. And the last one gets an x and an x minus 5. Now, on the first one times the 1, there's nothing to cancel. So it's going to stay just like it is. Well, anything times 1. So it's just going to be x times x minus 5 minus. The x minus 5's cancel. So it's just 8x equals. Now here, the x's cancel. So it's just going to be 3 parentheses x minus 5. Now, I need to clean all this mess up. Distribute the x throughout the first parentheses. So I get x squared minus 5x minus 8x equals distributor 3 throughout the parentheses. And lo and behold, what kind of problem do we have here? Hint. Okay, this is a quadratic equation. It's not linear, it's quadratic. So that changes things. How do we solve a quadratic equation? Well, preferably by factoring, possibly by the quadratic formula, both of which require it to be equal to 0. So my first step now, or my next step, not first step, but my next step is to subtract 3x from both sides, but also to add 15 to both sides, because I need to make this equal to 0. Okay, on the left side, I've got an x squared, I got a minus 5x, a minus 3x, and a minus 8x, all of which make for a negative 16x. And then I've got the plus 15. We're looking to factor this. General trinomial, x minus 15 times x minus 1, still equal to 0. Once you have it factored equal to 0, set each factor equal to 0. And solve each one respectively. So we get x equals 15. I also get x to equal 1. So we got two answers here. Are they acceptable? Well, if you remember, coming back up here, x could not be 5, x could not be 0. Well, we did not get 5 or 0. So therefore, both answers actually are acceptable answers. So we got two values for x this time. All right, and then now number 4. Now number 4 is a little tricky if you are not being careful. If you're looking at this, you might be tempted, and this is wrong, so don't write it. You might be tempted to look at this and say, that one needs an x minus 3. That one needs an x squared minus 9. That one needs an x plus 3, and you want to use all of it. It's technically not wrong. That is, like I said, it's not wrong. But if you do all that, you're going to end up with polynomial that's too big for you to be able to work with. You're going to get stuck. So that's not actually what we want to do in this case. Now, hopefully, because you got to see this for this problem to work. Hopefully you recognize right here that x squared minus 9 is a difference of two squares that will factor as x minus 3 times x plus 3. The rest of the problem is just coming along for the ride at the moment. Now, with that being said, this one tells us we need an x minus 3. This one tells me I need an x minus 3, which I've already got, as well as an x plus 3. And then this one says we need an x plus 3, which I've already got. So all of that, or that only, would be our common denominator, which is what we are actually going to multiply by. Whoops, got part of that 3 after all. All right, so at this point, I'm going to multiply every term by an x minus 3 and an x plus 3. X minus 3 and an x plus 3. Running out of room trying to squeeze that in. X minus 3 and an x plus 3. First term, x minus 3's cancel, so I'm left with the 6 times the x plus 3 equals. Here, the x minus 3's cancel, the x plus 3's also cancel. So all I'm left with is simply the 8x squared. And over here, wrong color, the x plus 3's cancel. So we are left with minus 4x times an x minus 3. Now we have an equation without fractions. Makes it a little bit easier. Distribute your 6. Distribute a negative 4x. And lo and behold, quadratic equations again. So, since my x squares are on the right side this time, I would move everything to the right. So minus the 6x, minus an 18. So I'm left with 0 equals 4x squared. 12x minus 6x leaves me with just a positive 6x and a minus 18. Have a GCF of 2, so pull that out. Leaves me with 2x squared plus 3x minus 9. And then now let's see if my general trinomial will further factor. If not, I will be forced to go to a quadratic formula. Two x and 1x is the only possibility for that. Plus 3 minus 3. Let's see, that would minus 3 times plus 3 would be a minus 9, but that would give me a plus 6x and a minus 3x, which is a plus 3x. So, yes, that works. Once you have it factored equal to 0, set each one equal to 0. So 0 equals 2, 0 equals 2x minus 3, and 0 equals x plus 3. 0 equals 2 doesn't even have a variable. It's illogical. Throw it away. We get x equals 3/2 right there. And we get x equals negative 3 here. But are those answers acceptable? Let's go back and look at this. All right, now it's probably better to go back to actually this step because that has this stuff factored. Makes it a little bit easier to see. So what is not allowed? Well, from our first fraction here, x cannot be a positive 3. From this one, it cannot be a positive 3 or a negative 3. And then this one tells us x cannot be a negative 3. So in other words, any answer is acceptable except +3 or -3. Well, in this case, we got -3 as an answer. Okay, we did not do anything wrong with the math. It's just not acceptable. If we use the -3, that would make us get 0 in the denominator up there, which is not allowed. So even though we got that answer algebraically, throw it away. In this case, all we have is the one answer, x equals 3/2. Had we done this and be left with no answers, then it would be no solution. All right, that's the general math behind your rational, solving rational equations. Flipping the page, number 5. Construction of the Rainbow Bridge in Southeast Texas took about 700 days to complete. If a second crew was added, construction could have been completed in 525 days. How long would it take the second crew to complete the job if it worked alone? All right. This is yet another version of our distance equals rate times time problems. Only, as we've said before, it doesn't have to be distance. It could be rate times time equals whatever the job is you're doing. You know, the rate you wash cars times how long you do it would tell you how many cars get washed, etc. So the rate times time equals whatever the job is that you're doing. Also, if you were to manipulate this, solve it for rate. So you would divide both sides by time. So my rate is distance divided by time. Okay, that also will correlate over here that my rate here is actually going to be the job divided by time. Okay, that's going to be important here in just a second. This type of problem, I call this problem, you know, two people working together. Okay, in this case, they're two crews working together. That changes things slightly in that we still have rate times time, but it's just of the first person or the first crew, plus rate times time of the second crew will equal the total number of jobs that they get accomplished, get completed. Still that same general idea. Now, in this case, the trick to these problems is fully understanding what you're looking at, because this right here says 700 days. When you read that, you should immediately think it's talking about the time, 700 days, but it's not, and that's where the problem is tricky. Okay, what they're talking about here is to complete the job. So one job took 700 days. So in other words, this is not a time, it's the rate. So this first rate is one job in 700 days. Now, what about the second crew? Well, the second crew, we don't know, because this right here is not the second crew. That's the two crews working together. If they are working together, their times are going to be the same. One crew might work faster or slower than the other, but they start at 8 in the morning, they stop at 5 in the evening, you know, or whatever it is. They start and stop at the same time, their times will be the same. So in this case, if a second crew was added, construction could have been completed in 525 days. That 525 days actually is the time. So the time for the first crew is 525. The time for the second crew is also 525. And we're wanting them to complete the bridge. So there is only going to be one total job. Now what we still don't know is the rate of the second crew. Well, it's going to be one job per unknown. I'm going to put C for crew. Unknown for C amount of time to do that one job. There is our rational equation. That is what we are solving. So now from that, pick it up just like we did page 1. Because of this, we have a variable in the denominator, but you still just identify what would be my common denominator. Okay, from the first term, this one tells me I need a 700. This one tells me I need a C. So my common denominator would be 700C. So I'll multiply this term by 700C, multiply this term by 700C, and multiply this term by 700C. It's only legal if you do it to everything. Here the 700s cancel. So what we are left with is C times 1 times 525. So in other words, 525C. Plus, here, the C's cancel. So we are left with 1 times 525 times 700. I'm just going to write out that at this point. And then over here, there is nothing to cancel. It's just 1 times 700 times C, which is 700C. Much simpler equation, no fractions. Linear equation. So let's get all the C's on the same side of the equal sign. So that leaves me with 175C equals whatever 525 times 700 is. 0, 0. 7 times 5 is 35. Carry a 3. 14 and 3 is 17. Carry a 1. 35 and 1 is 36. And then now simply divide by 175. 2 would be 350, which leaves 1, 2, 5. Let's see. That's not right. $175. There we go. Which is 1 and 2 zeros. There we go. Sorry. So glitch with the math there for a second. All right. So what did we just find? We just found the C, 2100, but 2100 what? It was referring back to this part right here, which was part of that rate, which was one job in C days. So what we just found was that the second crew would have needed 2100 days to have done the job all by themselves. All right, and then one last problem. Okay. This particular problem, I traditionally set it up as a 2 by 2, but it can be set up as rational equations as well. And again, since that's what this lesson is, we're going to set it up as rational equations. How much of a 70% acid solution should Mia add to 12 milliliters of a solution that is 15% acid to create a solution that is 60% acid? Setting it up as a rational equation, you're basically just setting it up with the idea that the part to the whole equals the part to the whole or the part to the total, whichever way you want to look at it. All right. So what we have is percent that is acid. How much of a 70% acid solution? So we know it's 70%, but 70% has no meaning by itself. It's got to operate on something. 70% of unknown, which is, we just call X, plus we're adding it to something. We are adding it to 12 milliliters, but those 12 milliliters are only 15% acid. So it's 15% of the 12. Now, how much total do we have? What is the whole thing? Well, we have unknown amount plus 12 milliliters. So equals. And what will our results be? Well, it's going to be 60%, but I don't know the total amount, so I can't really put that part. But just write the 60% as a traditional true statement fraction, which would simply be 60 over 100. That is the part to the whole, or the part to the total. And there's your rational equation. So again, following what we've been doing, this right here tells me I need an x plus 12. This one here tells me I need 100. So multiply everything by those. It's also important to note that all of this operates as though, because it's all the numerator, operates as though it's one thing. So we're going to multiply everything by a 100 and an x plus 12. 100 and an x plus 12. So this first one, the x plus 12s cancel. So we're left with 100 times all of that equals, and over here the 100s cancel. So we are left with 60 times the x plus 12. Now just do the arithmetic. I'm going to clean this up first. We got 0.70x plus 15 times 12, 30 times 6, which is going to simply be 180, so 1.8. I'll just wait and do this on the next step. Could have done it then. But when I distribute the 100, now that just moved all the decimals over 2 places. So I've got 70x. This actually is 180. Equals 60x plus 720. And get your x's on one side of the equal sign. Move your constants to the other side. And we found that we would want 54 what? Milliliters. Of that 70% acid solution is what we need. All righty. You know, and I forgot to mention on the previous problem, but I guess just to double check, is x equals 54 an acceptable answer? And if you're looking back at this, as long as it wasn't negative 12, it is acceptable. So, all right, that was lesson 73.